Hello, today we're going to get started with circles. So we have a lot of vocabulary words to look at, but this diagram over here off to the side explains those vocabs pretty well. So the definition of a circle is when we have a set of points that are a fixed distance, meaning the same distance from that center point. So starting at the center, it doesn't matter where I reach out to go to the side, but all of those are going to be the same, and that is our radius. So from center to outside is our radius. Our diameter has to go through that center, and it touches both outsides of the circle. So diameter goes from side to side, but has to go through that center. So that's why radius is half of the diameter. And then circumference, we'll be solving for circumference today. And circumference is if I would walk along a path following exactly the outside of my circle. Okay, so circumference is kind of like perimeter. Okay, it's the perimeter. But perimeter, we tie that with our polygons, and a circle is not a polygon. So up first here we have circumference. So find the circumference of a circle. So we have a formula for that. Let me get my pen mode here. So circumference of a circle, our formula for that. C for circumference. We use our pi symbol to represent pi, and we use a lowercase d to represent diameter. So circumference equals pi times the diameter. The way I remember that is I chant to myself, cherry, pie, delicious. So C is for cherry, pie, I didn't misspell it, that's how you spell pie in math, and then D is the delicious. So it's just a fun way to remember our formula. All right, so let's try it out. We're going to start off easy, okay? So if I tell you the diameter is 15, okay, we're going to substitute that into our equation, and the circumference is going to be pi times 15. Okay, but this, and to mathematician, is kind of a sloppy way to write that. So it says in the directions to write it in terms of pi, which simply means they want the pi symbol in our answer. So to write it in terms of pi, I would write 15 pi. And that would be my final answer if they wanted in terms of pi. But then it also says round it to the nearest tenth using the 3.14. Okay, so that means we're going to start at square one, but for pi we're going to use 3.14, and we're going to times it by 15. And you're welcome to use a calculator to type that in, and the circumference would be 47.1 feet is what I got. Okay, and it is just feet. Do not square your circumference. For a more accurate answer, using the terms of pi is your most accurate. As soon as you start using the 3.14, you're rounding your answer. So it is a little more rounded, but it does get you an answer. Okay, let's go over here, and this time I'm going to use the same formula. Cherry, pie, delicious. Okay, circumference equals pi times the diameter. But what if I give you the radius? Okay, so if the radius is 4, well, how does that help us solve this problem when I need the diameter? So looking at our picture at the top, if the radius is 4, it takes 2 of those radii to make the diameter. So the diameter is always going to be twice as long as the radius. So even if they give you the radius, you should be able to figure out your diameter. All right, in terms of pi, I would have pi times 8. But that's a little sloppy, so we're going to mix it up. And in terms of pi, our answer is 8 pi. But that may not help us if we're trying to measure something out. So using the 3.14 times that by 8, I'm going to get 25 and 12 hundredths, and I left out your unit again, so centimeters. Okay, and again, don't square it, just like we don't square our perimeter. We do not square our circumference. All right, so there's some cherry pie for you. Okay, so if cherry pie is not your flavor, maybe apple pie is more your flavor. So let's get out some apple pie for area. Area equals, maybe, doesn't want to come up, there's an equal, pi r squared. Okay, sorry that turned out kind of funky. Okay, so the little saying that I have for area is that apple pie R2. So cherry pie delicious, it won't let me move it, but cherry pie delicious, apple pie R2. Ignore that it's the bad grammar, okay? It's just a fun way to remember our formulas. All right, so let's take a look at an area question where we have to, or a circle question where we have to find the area. All right, so can you draw yourself a circle? Nicely done. We need a center. Maybe. This pen doesn't work well. All right, so, and I'm going to tell you that the radius is 9 feet. I didn't forget the unit this time. All right, so if the radius equals 9, so that helps us because, hey, that's what we need. We need the radius. Again, we're going to do this in terms of pi, and then we're going to use an estimate. All right, so area equals pi times the radius, which is 9, squared. All right, so we can clean that up in two ways. I'm going to put the pi at the end, and I can actually calculate the 9 squared. So 9 times 9 is 81. So in terms of pi, the area is 81 pi. But that does me no good if I'm trying to figure out how much stuff I need to cover that area. So I'm going to go ahead and use my 3.14 to get an estimate. So 3.14 times our 81 will give us 254 3/10 feet squared. Okay, so we're back to squaring things because we solved for area. Area squared units. Okay, so we didn't at the top. There's no squaring for circumference, but we do square our units for the area. Okay? All right, down below here we have what's called a composite figure. Okay, a composite figure is when we put normal shapes together to form something that looks a little bit crazy. So we have this shape here, and when I look at it, I see a rectangle. It almost looks like a square, but looking at the dimensions, I see 13 and 14 are different. So I'm going to find the area of the rectangle. Then I also see some semicircles. So the semicircles we're going to have to tackle a little bit different than just a regular circle. So we'll get into that in a second. So there's actually 2 of them. So we'll talk about that after we figure out the rectangle. Let's start with the easy part first. So area of a rectangle is going to be base times height. So we have a base of 13 and I see a height of 14. So when we multiply those together, we will get our area of a rectangle is 182 units squared. But that's just part of our composite figure. We got to figure out the rest of it. So if I'm thinking of this as a semicircle over here, and I know the diameter, it would be 14. Would you agree with that? If this is from side to side, we know the diameter is 14, but when I do circles, area of a circle, I need pi r squared. So if my diameter is 14, my radius equals 7. Okay, so let's jot that in, that our radius is 7. So 3.14 for pi times 7 squared. Now when I find this area of the circle, I'm finding the area of both of those semicircles if they were smushed together. So I'm actually finding the area of a circle. So since it's a semicircle, I normally would think, oh, I need to divide by 2. But since both pieces are there, it's just kind of spread out. I'm just going to find this area and use it as my circle. All right, so 3.14 times 49 is what I would be typing into my calculator, and I would get 153 9/10 units squared. Okay, so that is the area of the full circle. Whoops. So I'm just going to add these two together, and I would get my total area. So 153.9 plus 182.0. So adding up my two shapes, the rectangle and the circles, I get my total area. So 335 9/10 units squared because it's area. Okay, so composite figures, we're just breaking it up for common shapes that we see.